Okay, I think we can go. Can you hear me? You hear me? Is everything okay? Okay, all right. Hi, everybody. Thank you for being here after lunch with me. My name is Matteo. I work as a software engineer at Kinetics. And today, together, we'll try to answer one single, yet apparently simple question, which is, can we adopt Eclipse IoT projects on Android embedded devices? But before diving into the question, let me tell you why this is important. It is important because over the last few years, Android has gained a lot of traction as an operating system for embedded devices. With Android, we can build secure systems, production-ready systems, and at Kinetics, we've been using Android embedded devices for years. But as a software engineer, there is one question that sticks to my mind, and it is, how can we avoid reinventing the wheel? How can we reuse all the enormous amount of code from Eclipse projects on Android, not to miss what we've been doing for the last years? And so here we are with this investigation, see how we can leverage all the legacy code that we have and reinvent it on Android. So a few words about us. Kinetics has been working as provider for embedded operating systems since 2012. We've been working with many different vendors and other companies on a variety of use cases, and they've built a lot of expertise on embedded systems, also on the operating system side, but also in the applicative side. So we also write applications for embedded systems. We are members of the Eclipse Foundation. We have been since 2017, and are also leaders and maintainers of the Eclipse Hara project. So today, we'll first take a look at a few theoretical notions that we'll need to understand the effort of running Eclipse IoT projects on Android. The first one is JNI, and then the second one is a comparison between Android and the JVM on a runtime perspective. Then we'll move to our three case studies, Eclipse Hara, Leshan, and Mosquito, and we'll see how we managed to run Android clients based on these projects. Now, during the presentation, I won't be showing code because there is a great amount of code to be shown, and time is not enough. If you're interested in the technical details, please do come to me, stop by and ask you a question. We'll go through the code and the technical details together. So first, the JNI. Now, the JNI wasn't born with Android. It's been part of the JVM since, I think, Java 1.1, so since the very beginning, probably. But it's very useful in Android. It is useful because it lets us run native code written in languages different than Java, for example, C or C++. And we have many Eclipse IoT projects not written in Java, but written in C or C++. An example is Mosquito. So with the JNI, we can take that code, compile a library for a specific architecture or a set of architectures, and run it on Android. Now, of course, we'll lose a bit of portability with it because we need to specify and to set beforehand the architectures we are going to support. And we also lose some safety. We saw yesterday in another presentation that using the JNI creates some difficulties in memory management and parameters because, of course, we are going outside the JVM world, the Java world, so it's more complex to run applications. But it is also necessary, as I said, because many Eclipse projects were not born for Java. Also, Java code poses some challenges when it comes to running it on Android, and this is because we have different files, the archives run on the JVM and run on Android are different. So on the JVM, we use jar files. Jar files are basically containers of the bytecode, so of many class files, and they also contain some resources, but the structure of jar files is not that strict. We can have resources placed, for example, at the root directory of the jar, which is forbidden, for example, on Android. So on Android, we use APKs, which are somehow similar to jars, but with a more strict structure And also the bytecode that we have on Android is quite different. We have a single file called the DEX file containing all the bytecode for our application. Being the bytecode different, also the runtime between the JVM and Android is different. So on Android, we have a heavily optimized runtime for mobile devices and resource-constrained systems, because of course, back in the days, Android was born for mobile devices. And nowadays, it's being used for embedded devices where resources, power, computational power, and batteries are low. It is not only different on a bytecode level, but it's also different the level of the Java language supported on the JVM and on Android. So on Android, the Android runtime supports a different language level, and some features of Java are not available on Android. We'll see, for example, that Leshan makes use of some of these features, and this makes it difficult for us to run a Leshan-based client on Android. So now that we know these two main theoretical notions, how to run native code and how to run Java code on Android, we can take a look at three main case studies. The first one will be Eclipse Hara, which is a Kotlin library built with Gradle. Then we'll have Eclipse Leshan, a set of Java libraries built with Maven, and in the end, Mosquito, which is a set of C libraries. Now, the spectrum, the variety of these projects will give us a good look into how difficult it is to run clients based on these projects on Android. The first one is Eclipse Hara. So Eclipse Hara is a Kotlin library designed to speed up the development of Hawkbit clients based on the DDI API. Now, Hawkbit, if you don't know it, is an Eclipse project to deliver updates. So it allows us to deploy an update server, and the update server can deliver updates to a variety of devices, from simple microcontrollers to complicated servers. But the way these devices interact with the Hawkbit server is somehow difficult, because the DDI API are based on an HTTP interface, and of course, making HTTP calls is difficult. We have to deal with serialization, deserialization, request parsing. It's somehow boring. So what Eclipse Hara does is it wraps DDI API, providing a well-typed library for these devices to interact with the Hawkbit update server. Now, when we designed Hara, we made it so that it is operating system and architecture independent. This means that we did not rely on any specific structure in the jar or the APK file, and also we did not rely on any feature that was forbidden or not supported on Android. So actually, Hara works just fine both on the JVM and on Android as is, without any modifications. As a matter of fact, at Kinetics, we have an Android-based client interacting with an Hawkbit-based update server using Eclipse Hara. Now, we also have a small project named the virtual device, which emulates an embedded device and makes use of Hara on the JVM. So the same library, without any changes, can run the two environments because it was designed with portability and extensibility in mind. This is somehow different for Eclipse Leshan. So Leshan provides a server-client implementation for the lightweight M2M protocol, which is a very widely used protocol for remote device management and telemetry in the IoT world. So for example, you can imagine having tons of sensors gathering data about humidity, temperature, or whatever deployed on the field in places difficult to reach. So these sensors might have heavy power constraints, might run on batteries, might have very limited connectivity capabilities. And so the lightweight M2M protocol is designed for these types of use cases. And let these sensors send data to a centralized server. Now, what we did here with Leshan was trying to run an Android-based application using the libraries provided by Eclipse Leshan. Unfortunately, there were some difficulties at various stages of the software life cycle. So to start with, we had some build system tweaks. Now, Leshan is built using Maven, whereas Android uses Gradle. So the difference is Maven versus Gradle are not specific to Android. They will be present also if we were to change the build system of a JVM-based application. But with Android, we are somehow forced to use Gradle because that's the default build system. And so we have to face these challenges. For example, Maven handles differently than Android the transitive dependencies. So if we have two dependencies importing the same different versions of the same class into our code base, then Maven automatically mitigates the conflicts, whereas Gradle forces us to manually exclude one of the two versions of the class. Other differences are about the jar metadata. For example, Maven automatically merges all the jar metadata files, licenses, manifests, whereas Gradle, once again, forces us to manually exclude or mitigate the conflicts. At the code level, though, we had even more difficulties. For example, we found out that Leshan was using an XML parser which is not supported on Android. So we had to go in Leshan's code base, patch the code to ignore some exceptions thrown by the Android built-in XML parser. Other differences were about the resource loading. So for example, Leshan places a set of XML files at the root of the jar file. And when we import the library, those resources will go to the root of the APK, which unfortunately is not accessible on Android. So we had to go again in Leshan's code base, take those XML files and manually copy them into our Android application in the right location so that they were accessible from our Android-based application. Another difference was the network operations, because on Android, we cannot run network operations on the main thread, whereas in Java, we can. So we had to wrap basically the Leshan client around a dedicated thread to avoid having network operations on the main one. But in the end, it just worked. We managed to write an Android application using Eclipse Leshan, and we're now going to see a quick demo. So I can run a simple Leshan server here, running the jar provided by the library. And I have, of course, I have to restart the browser. I have the Leshan UI here, where you can see at the moment there are no registered clients. If I now go on my Android Studio, in my Android emulator, I can run a simple Leshan client, and what I need to specify is my IP address and the port, which is 5683, and then my device can connect to the server. Now, as you can see, the device pops up here, and I can read some information. For example, the manufacturer, which is Google, the model number, the firmware version. Now, this is all made-up information because, of course, it's produced by an emulator. But the point is that our Android client is communicating this information to the Leshan server. Even more interesting is the temperature. So our sample application is designed to generate random temperature values, which are sent every 5 seconds to Leshan, to the centralized server, and as you can see, are reported also in the UI. So the communication between our Android application and the Leshan server works perfectly, even if we had to tweak the code and the build system to make it working. Now, the third case study we're going to look at is Eclipse Mosquito. Mosquito is totally different. It's a set of C libraries implementing a message broker for the MQTT protocol. Now, MQTT is a very widely used protocol for in the IoT world because it lets us send very lightweight messages among different sets of devices. So it's a publish-subscribe protocol, meaning that the devices only need to know the address of the message broker. Then they can subscribe to a topic and send messages to a topic, and the message broker will take care of dispatching that messages to all the devices registered and subscribed to a specific topic. This means that the devices and the messages are decoupled both in time, because sending and receiving a message is an asynchronous operation, and location, because devices don't know to need about themselves, they just need to know where the message broker is. Now, again, this is a C-based project, and so in order for us to embed Mosquito on Android, we had to use the JNI. This is not actually a presentation about how we use the JNI in general in Java. We had a very interesting presentation yesterday explaining how the JNI works, but at a very high level, what we need to do is we need to specify and build our target libraries for different architectures, one or more, depending on the type of devices and architectures we want to support. Then once we have the binary files, the SO files, we just have to copy these files into our Android application at specific locations in the folder tree for Android to find them. And the most important thing is to develop the native wrapper. So the native wrapper is, generally speaking, a pair of source code files, one written in Java and one written in the native language, acting as a proxy between our Android or JVM-based application and the native world. So basically, the source file written in Java specifies an interface. In our case, it could be subscribe to a topic or publish a message. But the implementation of this interface is not provided in the Java language, but instead is provided in the native language. And the JNI simply binds any calls to our Java-based interface to the native implementation, and the native implementation can, in turn, interact with one or more native libraries, with the JNI acting as a binder. So in this case, we only had to embed the JNI into our Android application, and we managed to write another simple application using Mosquito. So in this case, I will run a simple Mosquito server message broker using the Docker image they provide. And I will run another Android application, which is the Mosquito client. Once again, I will have to type my IP address and a sample topic, for example, OCX 2024, and I can then subscribe to the topic. Now, as you can see, I subscribe to the Mosquito message broker with a specific topic, and if I go here in the logs of the Mosquito message broker, we can see that a new connection came in. Now I can leverage another tool in Mosquito's toolbox, which is the Mosquito Pub tool, allowing me to publish a message on a specific topic to a specific message broker. Now, if I publish this message and I go back to my Android application, you can see that it received the message with the right body on the right topic. So the communication is working. I sent a message to the message broker, and the message broker sent back the message to my Android client. Another thing we can do is we can create a new sample Mosquito client, subscribing again to the same message broker and topic, and as you can see, waiting for messages. And in my Android application, I can send some sample data, emulating an MQTT message. And as you can see, I receive the same message here in the Android application, because I'm still subscribed to the OCX 2024 topic, but I also received the same message in the other client that was running on my laptop. So the communication is working both between the Android application and the message broker, and between the message broker and any other subscribers or publishers deployed in different ways. And this leads back to our original question. So can we adopt Eclipse IoT projects on Android embedded devices? Well, the answer is yes. Yes, we can, but the porting effort is somehow different, and it depends on the project, on how it is written, on the build system, on the dependencies. Because as we can see, and as we saw during the presentation, some Eclipse projects use native languages, C or C++. Some others use Java features. Some are designed for being portable without effort. Some have some incompatibilities to cure. So during our effort, we had to isolate, for example, specific Java features that we could not have built in Android. We had to tweak the build systems. And the message here is that there is no single ring to rule all the Eclipse IoT projects. There is no single process to port any project to Android. It depends case by case. Now, this was an experimental investigation, but the results are promising. We actually can, even if with some effort, take an Eclipse IoT project, tweak it a little bit, and then have an Android client based on that project running on our Android devices. Actually, donating a second life and expanding the boundaries of Eclipse projects that were not born with Android in mind. So thank you very much for your attention. This will be all. If you have any questions, you can, of course, ask them here. You also have an email address. You can email if you have questions. After the conference, I will be around anyways, both today and tomorrow, if you are more interested into the technical details or have further questions. Thank you. We have a question here. Yes, sorry.
Okay, thank you for your talk. My question is, what is the benefit?
I'm not hearing anything.
Okay, I try it again. Okay, thank you for your talk. My question is regarding the chain I and the native porting. What is the benefit when you using chain I instead of using the native MQTT client, for example, and run it natively on Android? And maybe making the APIs available through Binder to a possible Java or Kotlin app running on Android.
OK, so in this case, the two solutions were actually equivalent. So we, of course, could have MQTT clients natively built for Android. This is not true in general, though. MQTT is very popular, so we have libraries for everything. Actually, also Eclipse Paho provides Android native implementations for Mosquito. But the point here is that when we encounter some projects that do not have that wide adaptability, we are forced to use GNI.
Okay, but in my understanding, when I have a C++ project, I can run it in Android in the machine room. Yes. So I'm beneath the JVM. There's everything written in C++ in Android. So I can maybe introduce a new service which is built with C++, and I can make the APIs available through a Binder IPC interface, right?
I have some difficulties. I am hearing their questions, but not yours. So I guess, can we increase the volume of the speakers? Can you repeat?
Okay, yes, I try.
Okay,
Oh,
that's perfect.
I guess now I'm. Okay, no. Yes, the point was when I have a C++ project. Um, in my opinion, I can run every C++ project in Android in the machine room. So beneath the JVM, everything is written in C++ in Android. So I should be.
Keep your microphone like that, otherwise it's not.
So better?
Yes,
That's better.
keep
Okay.
going.
Okay. Did you understand the question?
Yes.
Okay. So that's my point. So when I have binder and IPC, I can make everything available with C++ without needing the chain I.
Yes, in this case, it was more a matter of integrating with the application. So having this binding, of course, yes, we can run C++ applications on Android natively. It's a bit more complex when we need our Android application to interact with native libraries. So in this case, we need the JNI binding. Also, if we want to tweak the communication between our application and the native library, it's, in this case, still easier to use the JNI. In the future, it might be different. Also, the JNI is mutating. Now with Java 22, we have different ways to run native code with foreign functions and memory, I think, which could be supported on Android as well. So we have different possibilities. Of course, the ones that you are exposing is one of them. We could not fit all the possibilities into this single presentation. As I mentioned, the results are still experimental. But of course, also your use case is worth more investigation because it's still experimental. We are still exploring the best way. So yeah, it's worth a try. Thank you for the suggestion. Any more questions? We're good. Thank you again, and we'll see you around here. Thank you.